Hello and welcome to this video. In this video we will be talking about the decision-making tools that are generally available to the managers, especially under the uncertainty. Now the first thing is the problem that requires the decision-making process need to be defined, and the factors that influence it. Now under specific measurable objectives, a model that is developed more like a flowchart wherein specific points of decisions are represented by various nodes, and various options are then represented by a branch. So those kind of models are then used in conjunction with calculations of either maximum of the potential possible outcomes, that is on the optimistic side, also called as maximax, or uh, the best possible outcome under the worst case scenario, that is also called as maximum of the minimum possible number that may happen in the future, is generally referred as maximin. And the third one is the equally likely option, which is more like an average of the numbers that may happen under any circumstances. Now, the first concept that you'll be introduced to in this chapter is the expected monetary outcome, which is more like a weighted average. So I'm going to take an help of this textbook question. So there are information that is given to us is the manager has a choice, which is called intrinsic decision variables. This is what managers has control over to purchase a large stock, average stock, or small stock. Once that decision is made, then the nature's outcome, which is beyond manager's control and will happen, either one of these three outcomes will happen no matter what manager does in terms of large, average, or small stock purchase. And there's a probability associated with big, average, and small that is given to us as 30, 50, and 20%. Okay. Now, under each of these outcomes, no matter what manager does, we know certain possible outcomes in terms of monetary value. Okay. So let me make that clear. So these are all numbers. Okay. So as you can see, this is a loss of $2,000. Okay. So I'm going to fill up these numbers that I've developed a template to make things a little easier. And these are not dollar values. And rest everything else, it's going to happen twice. It's equals to 50 and then equals to 20%. Okay, and these are all control shift 1 as probabilities. And same thing as equals to this equals to 50 and equals to 20%. Okay, and these are also probabilities. Now let me bring these numbers here. I want to keep the color numbers for the calculated values, so I'm going to keep the probabilities here. Okay, and so on. Okay, and I will name these as nature's outcome, right? Yeah, so state of nature. Okay, so let's color these as given numbers in blue. Okay, and we are also given the stock values under big, average, and small for each of the options. Okay, so I'm gonna lay these out now. Once you get a hang of it, you can use the sum product that we've used in the past: big, average, and small. Big, average, and small. Now this is for the average stock, and then similarly for small stock and big, it's 9,000. Small stock and average is 8,000. Small stock and small demand is 4,000. Okay, so first thing is simply this times this. So similarly, we can calculate the outcome in each of the possible 9 combinations that are out there. So 3 the managers can choose, and then 3 the possible that will happen. So there are potentially 9 possible outcomes. So we have the expected monetary value in each of these cases. Okay, now um, instead of these individual branch, we want to calculate what will happen if the manager was to purchase a large stock. Okay, the way we need to look at this tree is, if this was to be our point of decision making, then we have 3 possible outcomes: 1, 2, and 3. Now each of these will have a branch value like this. Okay, there are sophisticated tools like at-risk and so on from Palisade corporations that will help in these kind of decision making. It's also similar to as to in a football game, which football is likely to reach the semifinal and final. But coming back to this question, so since we have the individual values for these branches, we want to calculate the expected monetary value at this particular node. Okay, now, so in order to calculate the expected monetary value for the large stock, we will say this plus this plus this. Okay, now if you notice from the previous chapter, this is nothing but a sum product, correct? We did the multiplication and then we added up. So if I was to do this time and time again without having to explain it graphically, then I can say sum product of this and this, and I will have the same number in here. But this is only for the demonstration purpose as to how the decision tools functions. Okay, so we have done this a couple of times in the past, but since I'm just showing you how this is done in a step-by-step manner. So if you notice, this is this plus this plus this. Okay, so these are what we call as expected monetary values. Okay, so these are all EMVs. And let me color this as, let's say, green I've already used. Okay, let's go with EMV, the yellow color. Okay, so now the expected monetary value for each of the node or each of the options has been calculated for large stock, average stock, and small stock. Now, as a manager, if the manager was to have the perfect information, that manager is going to choose which of these 3 options. It's going to be the maximum of all these 3, correct? So that means expected for a manager that is rational, unbiased, um, and is trying to either maximize profit or minimize the loss, that manager is going to purchase large stock if that manager can see the value of large stock, average stock, and small stock in the beginning. This is called as maximax, right? So at this point, it will make sense for the manager to purchase the large stock, because no matter what state of the nature happens, it is likely to give the manager the more value, which is highest of the 3 EMVs. Okay, therefore out of the 3 options, the manager is going to choose the large stock. Yeah, so this becomes the chosen one as the decision. Now let's say if we were to look at the state of the nature such that the manager knows as to what will happen in the future, which is what the text would call as expected value under perfect information. So let's say if the manager was to know that it's going to be a big demand or average demand or small demand. Therefore, let's find out in case of big demand, average demand, and small demand. Okay, so let me bring these, and I'm gonna paste these transports. So the maximum that a manager can happen, if it was already known with the perfect information to the manager that it's going to be the big demand, is this comma this comma this. So out of the possible outcomes for the big demand, the manager can expect to see 6,600. Similarly, it will be 6,000 under average demand, and it will be 1,200 under small demand. Correct? The manager is going to choose the maximum of this, this, this. So no matter what happens, it's going to pick the best outcomes of all the three scenarios. Okay. Now we know what is likely going to happen is, so what this is, let's make it bigger. So this is already known to us that the probability of big is 0.3, 0.5, and 0.2. Or let's copy this and paste this. Now, this is best of all the scenarios. If the big demand happens, then the best I can do is 22,000. If the average demand was to happen, then the best I can do is 12,000. Correct? Out of all these three. So let's say formulas, trace precedent. So this is best of all the three outcomes for that particular average. Now, this is based on the best outcome for the small. Okay, best outcome for the small. Therefore, this is what we would call as expected outcome with perfect information, wherein it's 0.3 times this plus 0.5 times this plus 0.2 times 6,000. Okay, so if the manager was to have perfect information, then it can, or he or she can look forward to making $13,800. Okay, so this is what we call as expected value with perfect information, also called as EWPI. Okay, so let's mark this as yellow and write this as EWPI. Now, let's say how much value would the manager put on getting this kind of information wherein it can do the best of everything. Okay, so that's what the text would call as expected value with perfect information. So let me write it down. Expected value with perfect information, also called as EVPI, is given as EWPI minus EMV. Okay, and EMV being the best of the EMVs, individual EMVs. Okay, so that will then turn out to be 13,800 minus 12,800, okay, which is here. So if the manager was to bribe somebody or was required to pay for consulting company, that would then tell the manager as to what is likely going to happen in the future. The manager should not pay more than 1,600. Or in other words, if this was to be, let's say in these days, these are the possible three companies of vaccines that can potentially cure the disease, and the requirement or the demand for the vaccine in the future can be big, can be average, can be small, then that company should not invest more than 1,600 in knowing which of these three companies, one, two, and three, which of these three companies vaccine will be more successful. So this is how the decision tools help in making a decision under uncertainty. Okay, so that's all there is, and then there's similar questions for practice, which you may try your hands on. Um, if you have any questions, feel free to email me. Thanks. That's all. Bye bye.